Hi OSLO users. In this video I'm going to show two things. I'm going to show the structure and how to build an SCP. SCP is called Star Command Programming. It is a precursor to CCL. I use CCL for everything that I can, but every now and then I run across a case where there is an SCP command that's called within some other routine, or I want to call some SCP command, and they are simple to call. You just do star and then the name of the SCP command. So this video is going to show you how to use those. The second thing is I'm going to show you a useful output file, a way to output your data from a lens file, a basic lens file, in such a way that somebody else can see exactly the full prescription that you have. And I've used that all the time. I use it to put a formula sheet around every design that I'm involved with. So the first thing I'm going to do is let's get a nice example lens open. So I hit Control O here, and then I come to the public location lens demo light, and within that structure there's this double Gauss lens. It's a nice example lens because it has a decent number of surfaces, an appreciable field of view, and speed. So that's the file I'm going to use. Now in terms of what I'm going to do at this point is we're going to go and open the Notepad++, and if we go to open SCPs, we can just open SCPs inside of the public directory. So here I open an SCP and I can pick any old SCP I want. Here you can see this one actually has arguments called to it, and those arguments are global variables. And at this point you might say, well, I'm really not familiar with SCP at all. Well, it's documented pretty well. Let's go here for a moment. So if I type in SCP here under search and the help, there's a number of things here. So here, SCP files, this gives you the format. SCP is limited in how you have to format them. You put star with a command name, and then you can string together a number of different CCL commands, and you can put numerous different commands within the same .scp file. The language elements, you can call some you can have some arguments that are called within there, but there's 6 and they're actually called with global variables. And there's some other sorts of things you can look at here. This was the language elements and then the components that you have. So if you're going to be building SCP, I do suggest you look through the documentation for a few minutes. In general, like I said, I tend to use CCL. So the main purpose here is to understand what an SCP is and if it's called within another routine. What I'm going to do when I build our file here is I'm going to later show a CCL version of it in another video that has a little bit more functionality, a little bit more flexibility built into it. So I come here, and this again is my Notepad++. I go ahead and close that. Now I have already built this SCP program that I'm going to use, so I'm just going to go to that. It won't take you very long at all to type it in yourself if you'd like to. So we go here to my OSLO Premium, and then we go here to the private directory. I want to put it in private because it's one that I'm developing myself. So I come here, and if we look, my opens a little bit off the screen. I've already got one written here, lensreport.scp. You have to save it as a .scp, and all I had to type in here was star lens report, so that's the name of the command, then pxs rtg wavrin. Pxs gives me the main paraxial parameters used to set up a lens, which for a system like this will tell me how to launch the light into the system and what parameters to set up within the lens spreadsheet editor to do that. RTG is the prescription for the lens, and it includes the glass names. The last two I always include in case a glass becomes obsolete or someone doesn't happen to have a particular glass that I've used in my design. This will allow them to understand what the wavelengths are. That's what WAV does, which are used as a reference for the refractive indices, which is what RIN does. So I could simply type these 4 commands into the command line, and great, I could instantly generate my report and write it to a text file and do whatever I want to do with it. But if I'm going to run this over and over again, or if I'm in a group and I want everybody's little report to look the same, I could build this little SCP. So I've got this built. There's no compiling or anything. As soon as I save it, and as soon as I save it as a .scp in this SCP directory, I'm ready to go. So here I do star lens report, and I hit enter, and there it is. That's my command. So this gives me the paraxial setup. This gives me the lens data, the wavelengths, and the refractive indices. So to conclude, SCP, you might see those routines called within other commands. It is more limited than CCL, but in its structuring, and we have that all documented pretty well. And then here's an example of a useful SCP that I've written that you can also do in CCL. The last thing before I end that I want to mention is these different commands that have been called in here, the PXS, RTG, WAV, RIN. You can go ahead and certainly look those up in the help directory in the program. And one important thing for me to mention is that this RTG command will print out the basic lens data, but if you have a lot of special data within it, it doesn't actually do that. So keep those types of things in mind when you do build your routines, that there may be some limitations in them, but boy, it's really nice to build a few routines like this to speed up your workflow.